Okay, good morning, everyone. We'll get started. Thank you all for being here, particularly on this last day of the conference. I know it's been a long conference. It's early. Many are still trapped in security. But hopefully we've saved the best for you for last, because we're going to speak about software-defined vehicles today, which is a topic that has been somewhat touched upon in this conference, but we're really going to dive deeper and particularly look at collaboration in this ecosystem. So I'm very happy to have three great speakers to join me in this session. So first, Sarah Gallian, Senior Manager, Automotive and SDV at Eclipse Foundation. Please a quick round of applause. You were at your own conference this week, so you drove from Munich directly here, so thanks very much for being with us today. Second, Michael Paulweber, Executive Advisor at AVL List and Coordinator of the Federate Project. Thank you very much, Michael. This is Michael's third conference this week, and next week he has his own conference. So again, thank you very much for being here today. Much appreciated. And last but not least, Geron Meyer, Head of Department European International Affairs at VDE Technik und Innovation GmbH. You've been here the entire time, so you can also share some insights from the CCAM perspective and from a broader perspective across EUCAD. So the way we'll run this session is each of us will give a quick keynote of a few minutes, touching upon, or perhaps I should also say, my name is Stefan Bogensberger. I work at Directorate General Communications, Networks, Content and Technologies at the European Commission. The way we'll run this session is, because SDV is related to a lot of topics we've touched upon, but we haven't gone into much depth, we will each give a quick keynote at the beginning, focusing on our different and complementary areas of work. Then we'll open up to a poll, and we really want to make this as interactive as possible. So in all slides we'll present, as on this one, you'll see a QR code or a link where you can participate with the code. We'd really encourage you to scan the QR code, answer the poll questions, and also for anyone participating in the live stream, you can submit your questions there. We'll also, of course, open up to the audience, but if anyone is very impatient and wants to ask a question right away, you can also, of course, do that over the Slido link. So without further ado, I'll say a few opening words about what we are doing from the European Commission side, what actions we are taking on SDV, and also relating it to the Automotive Action Plan. To start, why do we talk about software-defined vehicles? Because the industry is going a fundamental change where the value of the vehicle will change from mechanical components towards software-defined architectures. It is estimated that by 2030, around 50% of the value of the vehicle will be in chips, so in hardware and software. And for autonomous vehicles, the lines of code will exponentially increase that are required to make such a vehicle operate. So that is one requirement for the industry. The second aspect is that there is a high incentive to collaborate. Why? Because if you look at the software stack and the SDV software stack, many elements are non-differentiating. So if each OEM builds their own stack, if each tier has to integrate to a different OEM environment, there's a lot of redundancy, wasted effort, and time spent on non-value-adding tasks. So to put this in a perhaps quite provocative way, together with industry inputs from Roland Berger, we've put together a more provocative ballpark example of this. So if you think about SDV stack for any OEM to build, which would be estimated in the range of 2 to 3 billion euros, up to 70% of the effort spent by developers can be on non-differentiating aspects. So validating, integrating, testing. If now different OEMs would collaborate together, what we here depict as in gray, of course, there would be certain costs required, an adaptation cost to integrate into different ecosystems, the annual maintenance cost. But at the end of the day, for example, as we show here, if 5 OEMs work together, essentially each OEM would only have to contribute a fifth than 2 if they do it alone. So there is a huge financial opportunity of collaborating, but that also allows, of course, to free up resources towards more differentiating aspects of applications of the software stack to reinforce European competitiveness and strategic autonomy. The second aspect to highlight here is that we are seeing collaboration emerging if we look at our global peers and competitors. In China, the Chinese Automotive Association is really pushing for SDV collaboration between manufacturers. The smartphone manufacturers, Huawei, Xiaomi, are releasing open source kernels into the automotive ecosystem. And a recent example would, for example, be Li Auto's Halo OS, which they are announcing and have announced to release again in an open source environment. In Japan, the second and the third largest OEM, so Honda and Nissan, have announced an MOU to collaborate on a software-defined vehicle. In addition, the Japanese government has announced a Mobility DX strategy, so a dedicated SDV strategy. There are funding programs ongoing, such as to build a system on chip, which involves all large Japanese OEMs and Tier 1 suppliers. And in addition, if we look at South Korea, there is one large established OEM who's building their own ecosystem. So Hyundai is building an ecosystem on an SDV development group that also includes European peers. So what we take from this is that the global ecosystem is moving quickly at pace and also recognizing the value of collaboration. Again, and against this backdrop, there's also concerted action needed on the European side. So what are we doing? In the CHIPS JU, we have set up several projects and an ecosystem of involved partners. As you see here on the left, this is not mutually exclusive as new projects are coming in, but we have engaged an ecosystem which involves all large OEMs and Tier 1 suppliers, in addition to RTOs. During the strategic dialogue, which preceded the announcement of the Automotive Action Plan, in addition, a manifesto to collaborate on a European SDV ecosystem was signed by several automotive companies, as you see on the right here, and presented by the heads of the German, French, and Italian automotive associations to my boss, Executive Vice President Birkunen. So there is a momentum to collaborate in the European ecosystem. If we then look on from the strategic dialogue to the Automotive Action Plan and what was announced in the Automotive Action Plan, we received many questions, particularly on the European Connected and Autonomous Vehicle Alliance. And in there, SDV is an important role, but also an opportunity to build on the collaboration we have in SDV to the other elements that have been discussed in this conference. So what we have built in SDV is a Sherpa governance group where senior representatives of automotive companies meet to discuss the strategic orientation and direction under competition-compliant norms, which is an important aspect to stress from the Commission side. For that reason, we want to expand the scope, and this is what the Alliance seeks for. Here we have 5 elements that we focus on in the Alliance: hardware, so in-vehicle computing, the software-defined vehicle, AI models, autonomous driving stacks, and then also large-scale testing. And why I highlighted the software-defined vehicle component here is because working on software-defined vehicles is essential to be able to create open, interoperable standards, looking downwards towards the hardware, but then also upwards towards innovation, towards applications. So being able to work on open source building blocks, interface standards and tools is essential to build this ecosystem. If we think, and I'll cover this on a very high level, but what are the key principles we want to establish with this alliance? We want to push for a strategic direction guided by companies, not by the Commission, but by companies to set a roadmap towards autonomy, to provide a governance structure for collaboration, and extend what we are doing in the software-defined vehicle towards emerging AI models for automotive and autonomous driving. And that very much relates to the Alliance, I should mention, is very much innovation-oriented. We don't want to be lost in discussions on regulation, but of course innovation we promote have to be complemented by and build upon discussions that we've been having on the past days, for example, on cross-border testbeds. Our role is to facilitate and offer a framework for collaboration. However, this must be driven by OEMs and tiers. And in addition to that, and Sarah will definitely touch upon this, open source communities play an essential role in acting as an implementation engine and also promoting open source communities and methods for collaboration. We will provide public, or we provide public funding already for our actions on software-defined vehicles, it is important to mention that the core investments have to be made by industry. So public funding provides support and collaboration. It is pre-competitive, non-differentiating, and should focus on the element where there are mutual synergies for collaboration between companies. We aim, with the EU public funding, to build upon mutual synergies from national funding programs, so to not operate in silos, and also the announced future IPCIs. So to provide a bit more detail, what exactly we fund from the European level, on software-defined vehicles, you can think about this in 3 buckets. First, looking downwards towards the hardware, abstraction layers. So making sure that software-defined vehicle components are hardware agnostic, so that there's no lock-in to a specific ecosystem, but also an opportunity to cater for the opportunity to integrate emerging European processors into your stack. Second, looking upwards to also provide an API framework such as communication protocol, security systems, and data management. And then third, to focus on the DevOps lifecycle. So to have tools to streamline the integration, testing, deployment, and monitoring to move towards a continuous development and deployment process. These are some projects, and Michael and Gerion will touch upon these in more detail. But to say we have 3 large-scale projects currently under the CHIPS JU. The way the CHIPS JU operates is that the EU pays 25%, member states pay 25%, and the industry contributes 50%. Why this is an effective mechanism is that industry then has a skin in the game, and particularly also an incentive to use the results that are developed in European projects. Hardware abstraction layer, Hall for SDV, service-oriented framework, and shift to SDV, and a new call that closed now on developing AI tools to accelerate software engineering for SDV. Under CCAM, 2 projects are starting to also leverage SDV components for CCAM, such as for trusted AI and configuring up-to-date software architectures. And then under a separate partnership, the 2.0 partnership, we have 2 projects running. And as far as I can announce, another project which is planned for the 26-27 work programs, focusing on also implementing SDV architectures for zero-emission road transport. So we fund these projects. We are aiming to establish a strategic governance with the connected autonomous vehicle lines. But how do we implement this? And this is also a question that I would like to raise to the panel and for a discussion later on. We have our funding projects. These contribute towards open source communities, and open source communities can then be used directly by OEMs or through tiers to be used in commercial exploitation. First of all, does this transfer work? Do open source communities leverage and build upon the results that are disseminated in EU-funded projects? Is there an effective coordination mechanism also in between companies that are involved, between the R&D and then the series development aspects of companies? And second, how can we ensure coherence in project management to steer and incubate SDV developments? Our aim is not to create one European SDV architecture or one blueprint that will only be very limited in its use, but to create a framework so that companies can choose and are incentivized to build upon the open source developments they incubate in these projects in their own commercial roadmaps. So with that, I'll close by just highlighting what is currently happening, what we are planning next. There are several events. I mentioned the Eclipse events already this week. There are several other events, such as AutoSAR next week. We are planning to coordinate the governance with a senior high-level buy-in from chief software officers from the leading automotive OEMs and tiers, and also in parallel leading discussions from member states to be able to scale up and accelerate our SDV initiatives. In addition, to implement the Automotive Action Plan, a separate high-level dialogue will be launched by the Commission President before the summer break. What this means is that the alliance will be launched towards the end of the year. We have committed that likely in Q3 and Q4. So to close, we see a large incentive for collaboration on a European level. We see a need for collaboration on the European level. We have mechanisms in place, but we need to accelerate these and ensure coordination and effective governance to implement this. This is what I want to stress. I'm happy to discuss this further in the Q&A. But before we get to that, many concepts touched upon, but particularly the concept of open source is very important to us, open source communities. And so without further ado, I'd like to pass the floor to Sarah to explain this in a bit more detail.
Yeah. So thanks a lot, Stefan, for the actually great introduction around the significance and importance of open source. And I love that you made this business case, which is often required and requested. So I am going to start, and I hope I do not bother you too much, but I'm often asked, so open source is very talked about, and I know in the audience we have a lot of people from academia and academic background, so you probably know this already, but I guess you're not my usual audience. So I'm going to again answer the question, what is open source? And open source is all about the user freedom. And I hope most of you know about this, but the freedoms are, and we start counting from 0, the freedoms are you can run the program for any purpose. It doesn't matter if you're making money out of it. It doesn't matter if it's for your PhD thesis. So you can run the program for any purpose. You can study how the program works. It means you can go and read the source code, you can read the documentation, and you can make changes to the program itself. You can redistribute copies as they are. So you can take an open source software and you can sell it if someone buys it. That's fine, it is allowed. So you can redistribute copies as they are, or you can redistribute modified copies. So if you are a tier, you can leverage a building block developed in the open source domain, and you can make a customization for your OEM of choice. That is also something you can do. And you do not need to contribute your changes back. That's extremely important. So if you make a modification to a piece of software, you do not need to upstream it. Of course, if you find a bug, it is being a good citizen to upstream the fixes. But if you customize it for your customer, you do not need to upstream those changes. And that's extremely important and has been misunderstood for quite a long time. So what we foundations do is, in a nutshell, we host open source projects and we provide governance around open source projects. I represent the Eclipse Foundation, and we are the leading open source foundation in Europe. We moved to Brussels in 2021, and we are the home for community and collaboration and innovation. So what we, again, as foundation do is we do host the projects, but we do much more than that. In fact, we do provide governance and stewardship. And we make sure that our initiatives are run in a vendor-neutral way. And we make sure the IP, so we manage the IPs and licensing schemes. We create communities around our project and around our industry collaborations. We work with branding, marketing, and events so that developers don't need to worry about marketing. We provide an infrastructure and security, and just as an example, we have run a number of audits, of cybersecurity audits for our own projects, and that's a service that we offer. And of course, we work in the ecosystem development, and the Eclipse SDV working group is an example of this ecosystem that we have built. Next. Yeah. So actually, I love that Stefan made the case around, that made this business case and also highlighted the need to get together in a non-competitive layer to develop software. So what happens is that 87% of the organizations with more than 2,000 employees use open source. They are users, but they're not contributors. So there are many steps that we need to take. So I think that the role of open source in the automotive industry is very well understood, and everyone uses open source pretty much in either their tool chain or in the software that they build. However, they do not contribute. And I want to highlight that we don't only need contributors, we need to have leaders. So this is essential. We have seen examples again earlier of other countries, Japan, China, that are paving the way toward leadership in open source. And we, as Europe, we need to make sure we take the driver's seat there. Otherwise, so we need to do this to ensure our competitive advantage in the future. So not only contribution is essential, but also taking a leadership role, because if you are a leader in an open source domain, not only you are steering your resources, you are steering the resources of the entire ecosystem. And this is the key and fundamental aspect in being able to ensure viability for the future as well as speed. So I mentioned it earlier. So we, as foundation, we are at the bottom of this chain, and we ensure governance. So we make sure that everyone plays with the rules that everything's open and vendor neutral. And we heard earlier about hardware abstraction, avoiding vendor lock-in, and this is what we ensure. We provide the governance layer. And on the other hand, the organization that compete above what we call the value line, they come together with one another and work in what we call collaboration layer. So they work on technology and they define roadmap as well as build core capabilities. And this collaboration layer below the value line that sits on top of the governance layer is where the Eclipse SDV working group is involved in. So the working group was funded about 3 years ago. And we have already grown from 0, basically, to more than 60 members. And our members span from hyperscalers such as Microsoft or Amazon, through consulting organizations, through tiers such as ZF, Bosch, Continental, and OEMs. Mercedes and BMW, for instance, are two of the most active. So we have now a mass and number of members that allows us to truly focus on the goal of the working group, which is to build and promote open source software specification collaboration model so that we can put together a scalable, modular, extensible, and industry-ready, this is really important, platform. So, and this is not only a platform for code, it's a platform for collaboration and exchanging of ideas and speeding up the technology build. So there are 3 pillars that make the working group. One, as I said, is community, so community of our members, but we also try to reach a much broader ecosystem. And we get together in events throughout the year. We just had our Automotive Open Source Summit the day before yesterday on Stamberg, where we focused on changing the mentality at a management level, so at the people that actually make the decision to allocate their FTEs to open source projects. We have governance that I mentioned. This is what we as Open Source Foundation make sure that it's in place. We are code first. We ask active participation. We ensure vendor neutrality, transparency, and openness. Those are the value of open source. And then, last but not least, and most importantly, actually, we do have a wide spectrum of open source projects. These projects are more than 30, and they span from SDV dev, so tool chains, workflows, through cloud-operated systems, and of course, in-vehicle software. And what I'm depicting here is our wild landscape. So you can imagine that all of these projects, actually most of them, they are like building blocks. So they are building blocks in the middleware, there's communication layer, digital twins, and so on. We have orchestrators, some of them work in vehicles, some in the cloud. We have a bunch of tools that support the development of code. And we have real-time operating system. We have ThreadX, that's the first certified open source operating system. We have distribution and frameworks, and this is the trend. So while we first started with a bunch of separated building blocks, now we are starting to build distributions. And in fact, I want to highlight a few of these projects. Maybe the most active and most discussed right now is Eclipse ESCO, which endeavors to put together and to develop an open source, full stack that comprises modules across all the layers of the software platform. This is basically your glorified middleware. And the S-Core project is an open source project started at the end of last year that not only has software artifacts in the terms of requirements, feature, and of course releases, but also is putting in place a process. And process is extremely important in the automotive domain, as anything you do needs to be safety certified, because we are talking about software that runs in a car. And here is a very high-level architecture. I'm not going to go through it, but please stay tuned and check the project. There is going to be a first release, which is the 0.5, actually it's not even first, which is going to be providing already a critical number of building blocks. And after there is this first momentum, we want to try to get on board as many building blocks and as many contributions as possible. So check out the S-Core project. This is our first safety-relevant integration project. And safety is also a topic that the working group's been focusing on because it's of course a key enabler for having open source software running in your vehicle. And there is a really, there is a lot of questions raised because open source software is not developed in the same way, following the same process that you would do when you develop your software in-house. This is out of context. It doesn't have a clear roadmap. Not always do you have requirements, and you maybe don't start with the idea at the beginning that your software is going to be used in a safety-relevant domain. So. And here I want to highlight the Eclipse Trustable Software Framework, which is a project under the umbrella of the SDV working group. It is an open source project. And basically, this addresses the fact that if you think about how complex is your hardware, you have several multi-core microprocessors, and you have a non-deterministic hardware behavior. On the other hand, your code base, the size is just huge. It's millions of lines of code. So essentially, you move away from the framework where the ISO 26262 was developed, and you move over in a non-deterministic hardware and unspecifiable software with complex interaction. So the Trustable Software Framework is a groundbreaking framework to assess how trustable is your software, and is based on a number of claims. These claims that are in this framework are then given a score that allows someone to find out how trustable is your software, to provide evidence to these claims. And again, this is really a mental shift. This is a paradigm change, moving away from the 26262, which is not applicable anymore, really, if we want to be honest about it, and provides, and this is still in audit, so this framework has been audited by a certification agency as we speak right now, and hopefully by the end of the year, maybe early next year, auditing, this is going to be audited, and it will allow people that apply this framework to certify against the 61508, which is the mother norm with respect to the 26262. So this is another very important project to watch. And I think I gave you a very broad, very quick panoramic view of what our projects do. And of course, we as SDV Working Group are part of a much larger ecosystem. We are part of Federate, we are part of HAL4SDV. And and I think that's a good segue to the next speaker, which is Paul. And I'd like to call you to the stage.
Before I start, I would like to more specify in a little in more detail what SDV means in our context. Sarah already mentioned that we have a shift. We're extending the automotive software from what was in 26262 to something more complex. And there are a few important new features which we have to take into account, and which explain why we have to move to this new way of collaboration. On the one hand, one of the concepts of SDV is that the vehicle is changing even after it is sold. So the SOP is not the end of the development. You have continuous updates, which has a big influence in software architecture as well as software development. And I will go a little more into that, what is the consequence and how we want to tackle it in this open source collaborative environment. Second one is that we get with these updates and so a lot of more features which are not directly related to what we are used in the vehicle with the powertrain, with the driving. It's a feature that the car automatically selects a charging station and ensure that when you are arriving, it's available for you, or that tolling is done automatically, or that parking places are selected for you and that the vehicle automatically gets to the parking place and you don't have to worry about all these different payment procedures. This requires a lot of data from the cloud. So a lot of these new applications have a piece in the vehicle and another important piece in the cloud. And they have a completely different community out there. And we, from the development, we have to bring these different ecosystems together. Otherwise, it won't work. And the advantage is it allows new revenue streams. At the moment, the revenue is that you sell a car, you get, and you have to refinance all your development, and then you have maintenance activities, you replace oil or whatever. Here, you can have features as a service. So you do not need to purchase all the features at the very beginning. Customers have the choice to select them later, and they can have these updates and so on. This is something which is partially already in the vehicles for maps. You do that already right now, but there are a lot of new things coming on. What does that mean to the vehicle? And I tried to concentrate on the main difference, which Sarah already started to explain. I explained it from a different view. At the moment, the classical view is that you have lots of controllers, up to 120 controllers, and all of these controllers in a vehicle are related to a mechanical or electrical component, to a battery, to a seat which is moving, to a window which goes up and down, to an e-motor, power electronic, you name it. If you look closer to the software in there, the software typically consists of two parts. One is the actual control, which needs to be close to this mechatronic component because you have sensors and you do not want to increase the amount of copper you need for all this cabling and connectors and so on, because these are cumbersome and expensive. But there is another kind of software, which is automation, UI. UI is partially already in infotainment systems. But there's a lot of automation coming. For example, the car automatically closes the window when it starts to rain. And then it takes this information from the cloud where we have the weather prediction. This kind of software is moving to this high-performance computing, to the area which I would like to talk about. That's the software-defined vehicle area. And that's mainly about automation, comfort, edge-to-cloud applications, automated driving. Automated driving is some kind of a very specific application in there. And then you have underneath these controllers where you have really the hard safety topics, the hard real-time requirements, but they are linked to the components. And this is new central zonal architectures which are coming. If you look from the software side to it, we'll see that all of a sudden we have two kinds of software. We have the classical software, which is ISO 26262 related, with hard real-time, real hard safety requirements, but they are mainly in microcontrollers. And that will stay. From a development point of view, typically you have the V process there. The V process makes sense and won't go away because you typically develop hardware component, also mechanical, electrical component together with the controllers. And in parallel, you have to set up a production, or you have to adjust your production system. You have to make contracts with suppliers, long-term contracts. So it's ultimate necessary that at the very beginning you have really hard requirements which link the production to the product development, and then you have to follow the well-known V process so that when SOP is there, you can sell something. Therefore, we call that the SOP-driven approach, and that won't go away. There's a lot of software in there which still will be developed like that. But we have this new software, which is this automation, and this software which is this high-performance computing, which is changing over time, even after the vehicle is already in use and sold. And there, we don't know all the requirements at the very beginning because we want to increase the requirements. Therefore, we have this DevOps cycle that also helps automated driving, because there the technical system comprises all the environment out there, all the pedestrians, all the animals which the weather conditions, the road conditions, they're all relevant for an automated driving software. And therefore we are monitoring all the data. We are checking if something unexpected happens, and that has to get immediately back into our development process, and over the updates you can immediately modify the software. And that's a completely different software approach, and I will talk about the upper one, which is the new one. And I guess it's important that we separate that also within the companies, because they have different requirements, and both is valid, and there's nothing better or worse. You have to select the right one for the right topic. In order to achieve that, Sarah already and Stefan already said that we have agreed in a common structure with two very important interfaces. The one is this hardware abstraction interfaces, which allows that we add additional software, that we exchange the hardware underneath, especially for that we can replace it via RISC-V-based software or whatever. And we can immediately start software development because we can take existing platforms, might be ARM-based or whatever. And then we have this functional abstraction interface, which is a service-oriented interface, which allows to add on-the-fly new features to the software. And then what you also see, that in this new area, we have the two environments. We have the vehicle and we have the cloud. Both together allows us to bring in these new features. If you look from real-time requirements, then you see that you have still the controller software area there. It has also similar structure. That's the hard real-time requirements. There you have most they have a lot of regulations out there. In the more soft real-time, so automated driving is still real-time, but it has underneath an AAP, for example, which stops the engine if something unexpected happens, independent whether a manual driver is driving or an automated driver is driving. What we also agreed, and Sarah said it already, and Stefan, that we agreed that we want to have a modular building block environment, that we do not have just one architecture. We have to have reference architectures, reference stacks, but they have to fit to the needs for the different customers. And there will also be different stacks for automated driving, for infotainment, for body control, and so on. So that won't be the same. But the building blocks, to a large extent, should be the same, especially for communication, memory management, and so on. So, can that work, this collaboration? We tried to figure out if something is working, then there's a big interaction, a big contribution, a big involvement of tiers and OEMs and academia, open source initiatives, tool providers, engineering service provider required. As Sarah said, we need leadership and we need contribution in order to be able to use it. If you bring something in and it's open source, as Sarah said, business models are changing. You don't get directly reimbursed for your activities. The question is, now can that work? Is there something which you can get out of these initiatives when you are participating? And if you look for OEMs, Stefan already explained that this collaboration allows you to share development costs for these non-differentiating areas. That's clear. It's a little more difficult for tiers. What's in for them? And for them, if they participate, they know exactly this architecture. They can do integration, sell integration service, to adapt it for OEM specific. They can do testing, they can do certification of the stacks, because that will still be required, maybe using this trustable framework which Sarah mentioned, which is currently under development and hopefully soon even standardized. And they can bring in their own specific building blocks, because as they are participating in this generic structure, they know exactly the interfaces, and they can sell also non-open source building blocks in addition. Academia is important. They should also bring in building blocks and especially integrate building blocks with new technology, so that we easily and quickly see what the consequence of new technology is. And technology is changing very, very rapidly. So the speed of change in technology has enormously accelerated. And academia are valuable contributor, especially in the open source development. They can now bring in new building blocks, and we can easily, quickly see what's the value, or if it doesn't work, what's in for them. They get lots of interesting topics. They can make, that's a hype topic at the moment, so they can make a presentation and papers, and they can even get public funding. What they have to do, they have to bring us students which are trained in these new environments, because in the industry we have a lack of experts in that, and therefore the participation of academia is utmost important. OS initiatives, I guess, I don't have to stress too much. Sarah told that they have the experience, the technical guidance, the community building experience. What's in for them? Yeah, they can grow their community. They have the opportunity also to sell something to, for example, trainings or so to members, mainly done via their membership fees, so that they can offer that. Tool providers, they actively have also to contribute to bring in tools, and tools are then open source, which changes also their business model completely. But they can save costs, because they can share the development, and they can sell integration services and also specific apps which speed up things. Okay, I guess that's the most important one. Let's take now a closer look from the EMBOS perspective, how that can work. As Sarah said, we are developing building blocks. That's done in open source projects. Eclipse SDV is one of these initiatives, but the others out there, Covesa, Sophie, AutoSize moving in the direction, OSRA or OSI, or so there are lots of them. At the moment, our leading OSS initiative is Eclipse SDV, because they spend most of the effort to build up that. And they provide processes, ways how to interact, and also they have these ways that how the building blocks are published and so on. And what we need then, also Sarah said, we have the SCORE project, which is doing the integration. And integration shall lead to what I call reference stacks. And there will be not just one reference stack, there will be many reference stacks. There is also not just the SCORE project in place, also the truck providers have started a joint venture, and they might also create reference stack using these, and there might be others which can do that. So we will have a bunch of reference stacks. In order to integrate, you have to orchestrate, and Eclipse for SCORE, they are moving into that direction, so that we know which kind of building blocks we would like to have, and there's also some negotiation for interfaces required, otherwise it won't work, otherwise you can't integrate. And also, that's already started in Eclipse SDV. You have to ensure that a certain quality of the building blocks is out there, which is then visible via patches, so that you can know how is it already in use in commercial projects, or is it just an academic prototype. I guess that's important that that's known. In addition, we have this public funded projects, Halfo SDV, Shift to SDV, the new tool project, and in Federate we're trying to bring the open source community and these projects together. What's important to understand is that for these funded projects, it's a different situation because we expect that in the funding projects, you have two things typically. You have use cases, which are then decomposed into tasks which you have to do. And these tasks, should be, to most cases, projects in open source initiatives, because for us it's important that the result of such a public funded project, it doesn't stop to exist when the project ends, but we need the open source processes that it continues. And we also have to, and there can be two cases, either there exists already an open source project which is extended, then we have already the organization. If there's not there, then we have, together with Eclipse or Covesa or whoever, we have to start such a project. That's ultimately necessary. And the second task is that they use these projects, maybe with non-OS open source components, which will be mainly necessary for use cases in this non-differentiating area. In order to have a stack for automated driving, you have also some kind of perception and all these other automated driving features, which might not be open source, but in order to do the use cases, you need that. So that's what they deliver also back, how good these reference stacks are working. We have then the tiers which can take this reference stack, extend it to specific customer stack, do all the certification, the testing, and so on. That's what a lot of tiers are doing right now already, and the OEMs have the choice either to use specific stacks from the tiers, or they can start from the reference stacks, or they can have their own stacks using the components from this open source environment. What we need is some kind of a governance. Here we have what Stefan said, the activities going on in the commission, and on this orchestration layer, what Sarah told us. So that's going on. Just to show you which kind of project we have, and I can be very quick because Stefan mentioned it. I just want to add that we have also project in this hardware layer to create an European hardware platform, which will also fulfill this hardware software abstraction layer so that it can be used and we can replace existing hardware with the new hardware. And there we have even more projects when we have projects at the moment running or in the proposal state on the software side, 210 or 220 million. In the hardware side, we have about twice as much money involved. And the goal is really to have chips which can be used in vehicles out there. It's chiplets and SOCs and all that's included. What we have set up in Federate to help the community, we created a building block in inventory, which is also open source. It's a Git application where we try to collect all the building blocks out there from the different initiatives, the different projects, together with some information about the status. And that's something which we in Federate will continue to support. And you see, we have already a significant number of building blocks in there. Won't go into detail. If you're interested, you can use this QR code in there, or you can go up to Federate EU, Federate SDV. There you can find the QR code and you can select it. What we need is governance and for orchestration. And I guess I can also be quick because Sarah and Stefan already mentioned that there are different aspects. We need architecture to maintain, otherwise we will never get reference stacks. We need also some kind of interaction and governance of the different projects. And we see we have a lot of open source projects. We have public funding projects. They have interlinked. That needs continuous moderation. Otherwise, you have misunderstandings and it won't work. And also these reference stacks, especially if then several projects are out there for trucks, for passenger cars, then you have to maintain that. We need some marketing also, what Sarah is doing, what I try to do partially. We have a technical ambassador at the moment We need ecosystem conferences as we do it right now. We have to even spend more effort on quality checks. We have started, but we are not at the end there. And we have to ensure that we have some kind of an independence to the different activities. We have national funded projects, we have EU funded projects, we have Eclipse, we have other open source initiatives, and all should work together. So we have to ensure that we are not have a login. And that leads me to the end.
Thank you, Michael. And despite your several conferences, you're definitely not out of breath. Thank you very much for this detailed presentation. Now we'll have a bit more of the CCAM angle from Gerion. So over to you.
Yeah. Thank you very much. Oh, okay. All right. When I had the opportunity of, and also the pleasure to moderate the session on key enabling technologies yesterday morning, I said this is the nerd session, but I have to correct myself. The nerd session is here. And the reason why I'm saying this is because I think what Sarah and also Michael have explained in much detail is a tremendous shift in mindset. Yeah? So it's completely different from the way we also in the CCAM partnership, from a little bit more traditional point of view, are talking about technology. By the way, CCAM partnership is more than technology development. It is very strongly and deeply the interplay between developing enabling technologies and using them, but at the same time also considering the societal dimension. Societal readiness is an important perspective there, and the question of how to, by technology development and connected automated mobility, meeting societal demands. I think we also need to keep this in mind. And in this view, it's particularly, I think, a nerd session that we are looking that deeply into a particularly very exciting technology development here with software-defined vehicle. Let me say 2 words about my own role in the CCAM partnership. As some of you may know, I'm representing the European Technology Platform on Smart Systems Integration there. That is EPOS, and we are, by definition, looking into this whole stream of sensing a situation, controlling a situation, deciding, and then acting. But that certainly is the old ISO 26262 world that Sarah was mentioning. And that is at the same time the paradigm under which we are looking into technology development in the CCAM partnership so far. That is the mind shift that I mentioned, and that, of course, we need to face and manage here. The other matter is that also through this role in the EPOS, or representing the EPOS technology platform, we are directly involved in the CHIPS joint undertaking as one of the 3 private partners, besides the Insight Association, which is the software part, and INEAS, which is the chips developers part in it. And thereby, I think we are kind of in charge, in a sense, to look into that link. And of course, I'm happy to comment a bit from that perspective. So let me maybe tell you a little bit how so far, altogether I have some 5 or 6 or 7 slides, so hopefully it will be done in 10, 15 minutes. Yeah? So we have a bit of time, hopefully, to discuss as well. The first is I'd like to, just from a practical point of view, let you know how in the CCAM partnership we have considered and covered the link to the software-defined vehicle development so far. And I'm immediately saying, when we are talking software-defined vehicle here, we are also thinking software-defined plus also hardware-enabled, because that link also has been made very clearly, particularly by Michael, saying that we also need to consider all these changes in the electronic system, the chip system, and how they interrelate. So first thing, therefore, hopefully the slide comes up. Yeah. How do we cover cooperation between CCAM partnership and the software-defined vehicle initiative in the CHIPS joint undertaking right now? And the instrument for doing that is our strategic planning process, which in both cases, so both the CCAM partnership as well as the CHIPS JU are having that. Yeah, so we are having this the strategic research innovation agenda of CCAM, and you see this picture here, like a bit the same level of complexity like on the previous slide. So this is the world around the CCAM partnership, and it's related to many different other activities, and one of them in that version of the strategic document that was released, I believe, early last year, it was still called KDT, so Key Digital Technologies, which now is the CHIPS joint undertaking. And it's pointing out a couple of areas of collaboration. The first was the development of an open reference architecture, because we understand that there is this fundamental shift of what an architecture is. We heard that Sarah and also Michael were talking about these building blocks that are kind of, in a sense, something that imply a certain level of flexibility as well for certain functions. And as these worlds of software and hardware coming together, obviously, there is a big change that needs to be covered. The second is the reference implementation piloted in CCAM projects. CCAM projects at this level are not yet doing that with software-defined vehicle architectures, because this is a very new development. And keep in mind that the first projects, also those that have been mentioned, are just starting now. Yeah, but it's something to be done, of course. Sensors and AI systems is a very obvious area where hardware and software are coming together. We are talking about AI at the edge, the capabilities of sensors to perceive an environment with low latency and to react quickly. Cybersecurity communication infrastructure is another one. When we are talking cybersecurity, we oftentimes think of the communication with the cloud, but also keep in mind what masses of data and what bandwidth of data is used inside the vehicle, and that, of course, needs to be shielded and needs to be encrypted and so on. Active safety and assistance system is the most obvious application domain, of course, and software-hardware interface design is a crucial point. Also, I still love this idea with the hardware abstraction layer, but still hardware abstraction means software here. So ideally, of course, it would be one entry point, one computer that's controlling everything. We are not yet there, and it's a smart concept, I think. So, but we need to talk about that, I believe. So how is this practically done? So this is from my own notes in order to keep track of all the different calls for proposals that have been released during the last 3 years. So this started 2023, so 23, 24, 25. This is what we have. And we talk a bit about 2026. And you see this is, and it's a bit similar to the picture that Michael has shown. We are addressing all these different layers. The blue ones are the ones from the CCAM partnership. First one last year was a call on architecture, and particularly looking into software and electronics. But then in this year, actually it's called 26 now, but anyway, because it's the deadline is in 26, it's about perception, and we have one on AI, and we are talking about one on Gen AI for the years to come. At the same time, as you can see, the CHIPS joint undertaking on the one end is having this focus on software-defined vehicles in the upper part of the stack, and then also I believe Michael mentioned that heterogeneous integration chiplets and RISC-V microprocessors, which is an open source architecture for processes. So all of this has to come together, and it's covered quite widely. Again, a bit more practical. How is this done? You can read through the core texts here. For example, from 2024 was the first one on electronic control architecture for CCAM with the use of the software-defined vehicle concept. Now we are having one on environment perception, real-world operations, again making clear link to the software-defined vehicle. Then the one on AI for CCAM systems, and then a big topic that we are talking about for 26, 27 for Gen AI, for smarter CCAM, and that's actually a cross-cluster topic in the CCAM partnership, connecting the 2 technology clusters, 2 out of 7. So the others are not directly tech development, just 2 other of them. One is vehicle technologies that I'm having the pleasure to co-lead together with David Storer from Klepper, and the other is the enabling technologies cluster, which is more looking into AI. So this is the world we are in. And maybe the interesting thing is, where do we build our part of the we're seeing a big bridge being built from the software-defined vehicle domain towards CCAM. That's much appreciated. But where do we build our bridge? And our bridge is by clearly saying in the call how we understand the opportunities of SDV here. And it's therefore in all the call texts you read that there is a call for collaboration with the software-defined vehicle initiative. Sometimes it's also saying, and the hardware parts in it. It's encouraged. It shall adopt the interfaces and building blocks or propose new ones. And that's exactly the mechanism that was mentioned before with this GitHub. Yeah? So where all the building blocks, and you may remember Michael's picture with all these building blocks in it, where you can, of course, take advantage of those, or at the same time, we encourage the participants here to provide input to those in order to further enrich it. Yeah? So that's the idea of the collaboration. I would love to show results of projects, how they are doing. Actually, they are not yet there. So, Stefan, you mentioned some. There's some more on architecture, but they're all just starting right now. So we are really curious to see how they will implement that. Let me point out one more thing here, which I believe is important. Maybe you may say, Sarah may probably say, oh, that's the old world, yeah? But, okay, so from the discussion that also Michael in his opening words mentioned about decoupling. I mean, that's a great opportunity. Of course, ideally, an automated vehicle would be something like this, right? So with the software being the iOS, updates it overnight, and then the vehicle is becoming more intelligent while we sleep. But that's just one part of the story. And if we develop software and hardware independently, that might be an interesting functioning system. But is it also efficient? Is it safe? Is it reliable? Yes, Sarah, these are old world dimensions, I understand. But we cannot forget that. So obviously, there is a lot of functions in it that we also need to consider, and that make it more difficult. Well, in this newest version, latest version, I'm happy to have that from Apple. They are saying that they're covering all of this. Some of you might have seen this little movie with Tim Cook talking to Mother Nature about things, and so they are considering these things. But it's important to understand that decoupling for an efficient and acceptable and feasible system, it also requires co-design. And that's the point that I'd like to stress. And Michael and I, we had some discussions about the dilemma of co-design versus decoupling a while ago. And the problem with the dilemma is that it doesn't let you sleep, right? And here's a little take on it that we had, and this is my second last slide, so no worries, Stefan. This is a little slide that Georg Stettinger from Infineon yesterday showed in our key enabling technologies session, saying that, okay, the decoupling phase is something that particularly applies to the deployment and product phase. This is what we want to have at the end. Yeah? The co-design is something we need to do during the development. Yeah? That is what we need to consider in these phases of research and development and innovation. But he also said it has quite some implications. And I remember one of you saying the development does not stop with SOP. Yeah, it does not, because this component that then was provided, say, by Infineon into the system in the past was just a product they had sold up, and then whatever the OEMs wanted to do with it was that was their business. But with this decoupling, there is an opportunity for the two to renegotiate what they are doing here, and with, for example, Infineon also still having a grip on their parts and being able to learn from the usage and to improve. So that is where the development process continues. Well, I would love to tell much more things, but one more thing, because I like, Stefan, I like your temple, and I have, if you allow, would like to make a little comment on it. And much of the things that I have here, you have already covered in this graph where you talk about the key principles of ECAVA, so I think that's the term you use, a European Connected Automated Vehicle Alliance. Yeah, I just would like to echo maybe what is said there. We had a lot of discussions about how to coordinate further the cooperation between SDV and CCAM and other of these application-related partnerships recently, and we felt there is a high level of coordination needed, particularly there in the roof where we see this little European Commission icon. I would say, yeah, yes, of course, take the lead, but please keep in mind this is a very important role. And you already said we need to share it, or it's even up to the industry to play a role in it. So I think that's an important one. Just the points here. Why is it important to make links between the different columns of the temple that are hardware, software, AI, automated driving, and testing here? Because in the end of the day, it requires this comprehensive software and hardware reference architecture built out of non-specifiable hardware, if I understood correctly, and trustable software. So that there's a lot of trust and joint understanding that need to come together. So that's absolutely needed to have that good roof. And the second is forecasting, strategizing, planning are in a joint roadmap. You mentioned roadmap already, and I believe all of us who are in these different worlds may feel that there is a need to cover or to close the gaps in language and understanding that we have, and a joint roadmap is the method of doing that. Briefly, some of you mentioned what implications we have on the development process. Yeah, I mean, how has a car been built in the past? You had requirements, you had development teams working 2 years separately of each other, and then you put things together. Hopefully it worked, and if not, you had to restart the process. Software development is different from that, and hopefully that is an opportunity for accelerate, but we need to understand, we need to learn from past initiatives and keep in mind the legacy, grow the ecosystem, align with member states, you already mentioned that, and also with industries. And finally, there's one point that I'm still struggling a little bit with. Reading the action plan, I love this innovation and digitization chapters. It has so many different measures in it, and the ECAVA is very clearly visible there. At the same time, there's talking about in IPSE, Stefan, you mentioned that, there's also talking about a joint undertaking. So a big action, probably the continuation or whatever that builds on CCAM 2.0 and things like that in the future. Honestly, from knowing a bit what an effort it was to set up the CHIPS and KDT joint undertakings, I believe if we want to have this running from the 1st of January 2028 on, we not need to start doing that yesterday. And maybe the Alliance would be a good way of thinking of that, but it's just an idea to make efficient use of the different instruments. Thank you so much.
Thank you very much, Gerian, and also for that call to action. So I mentioned we have a poll going. If you haven't answered it yet, I would very much encourage you to submit your responses to that poll. This has not been a topic light session for the morning, but we hope you've got several very interesting insights, and I'm particularly very thankful for the speakers. But before we go to the poll, I'd actually now like to ask you for questions and see if you have any particular inputs, insights, comments, remarks that you want to directly pose to the participants. So if you have any points, please raise your hand and we'll try to get a microphone to you. We'll start at the front here.
Yes, thank you. Christophe Rombaut from the Flemish Agency for Roads and Traffic. Maybe a question to Mr. Paul Weber. You saw me smile a couple of times because this nerd from the road agency gets very happy when I see these kind of architectural pictures. I saw on the right-hand side of your architecture picture for not real-time applications, the road operator. So I was very happy that we are already in there. For non-time critical elements. I was wondering whether the reference architecture today also already keeps in mind that we are transferring quite dynamic information as well. So not the roadworks which are quite static, but like information on intelligent traffic lights, signal phase and time, ghost riders for the V2I to V applications. So which I think are maybe not full real time, but near real time. To what extent has that concept of using extra information from a road operator already been pinned down in this reference architecture?
I guess, can you hear me now? So your remarks are very good, and I like them, because I see one of the tasks, especially together, and also of CCAM, to help us to bring together these different communities, because road operators and cities and so on, they have first to collect all that information, make it available for all the different manufacturers, for Toyota, BYD, BMW, Mercedes, you name it. That's something which has to be done within in the cloud, in that environment, but we have to do it together. And I guess CCAM is the perfect community, because at the moment you're collecting that. And I guess within, so we have in our structure, we have implemented that and have foreseen that. But now we have to find the right people really to create building blocks in the cloud, as well as in the vehicle, in order to communicate. Communication, I guess, that we have, that's in there, that's foreseen. Now we have to bring in a little more the application, because that's also required. But it's not just road operators, it's also parkings, garage operators, it's tolling, it's weather conditions, a lot of other things which have a similar situation. And I guess that we have to learn that it's the OEMs, they cannot do everything on their own. They need, also the bidirectional charging, for example, you have the energy community in there, so that and if you use vehicles to stabilize the grid, that needs interaction. There are lots of things which are possible with software-defined vehicle with this architecture, but we have to establish, we have also to work in the cloud with other communities, and we have to synchronize that. That's another governance topic which we have to do, and we have to create then small specialist groups to really to work out the details, using the communication methods and so on, which we have already foreseen in the, let's say, the core of the stack.
Yeah, maybe I can quickly add to this. Yeah, thanks, Michel. So we do have, in principle, in our stack, we already have a number of communication protocols that also work with the cloud. We have some orchestrators that run in the cloud as well. We have Grafana, which is like a dashboard to gather data. So we do have a few building blocks that are supposed to run in the cloud. What we miss are use cases. So that would be already actually very interesting to know and to see whether there is any gap that needs to be filling in the lineup of projects that we have.
Thank you so much.
Great. We'll maybe take two at a time. So first here and then back there.
Hello, good morning. Gerhard Menzel from the Austrian Ministry of Transport. I have a bit similar follow-up question also to DG Connect and probably also the panel. The session is called the Vehicle Alliance. You've presented it, and I think you've all tried to see your view in that regard. It links to this question: what is the role of the member states then? I think we said it's an industry alliance. Then on your last slide, it was, okay, discussions with member states needed. I think so too. But, and then we hear now, okay, infrastructure operators should be involved. I mean, are they? I'm not sure. And the same also for parking operators and so on. So how does this fit together? Also thinking about the discussions yesterday on all the different fora, I think this is something that should be tackled, and I wonder what your view is on this.
Thank you. And yes, we had two more. Let's take the one at the back, and then David will get you in the next round. At the back there. Sorry.
Hey, I'm Thorsten Schön from Technische Hochschule Ingolstadt. So I have a question to Sarah regarding the Eclipse SDV. So I know that the SDV is covering the whole vehicle, but especially for the CCAM components, is there any interconnection or integration with ROS and AutoWare? planned?
That's an excellent question. So, yeah, with Outerwear, of course, we are aware of the initiative, but yeah, we still need to get in touch with them, honestly. I mean, we know, of course, about them. Regarding ROS, well, we have a couple of projects that are based on ROS. For instance, we have like Mutu, which is a project on it, and also we have View Protocol. So we do have projects that already use that paradigm.
Okay, thank you.
Great. And then to respond to the first question, I'll have a comment. Or Geraint, you still want to respond to Ross? Okay. Good. Then I'll say a few things. So the Alliance, I completely agree with your comment. The purpose is not to create new structures for having discussion fora and just to discuss for the purpose of discussions. The aim of the Alliance is to have coordination and a strategic higher level buy-in towards key technological trends that we have to make and shape together to reinforce European competitiveness and strategic autonomy. What that means is that industry should set the direction and should receive an environment to be able to set such direction in a competition-compliant way. The role of member states here is essential for several reasons. On the one side, because member state funding programs shouldn't be completely decoupled or separate from what we do on the European level, but also because several of the programs we have, for example, in the CHIPS JU, have the strong buy-in and cooperation with member states. So we encourage strong participation from member states. The member states will have a dedicated role in the Alliance. I think the good reference cases to think about are, for example, there's a semiconductor alliance, there's a cloud alliance, right? Member states have dedicated roles in there, and they have dedicated ways to be able to contribute actively from the beginning on. What we don't want is to have a consensus-oriented decision fora where decisions are limited to, let's say, the minimal viable outcome. We want industry to drive discussions, to push forward progress, and to really try to adopt solutions or have strategic orientation at scale. So we are currently discussing the terms of reference. We are actively engaging with member states. We also look forward to those discussions. But we don't want to have a situation where we are limited because we need the consent of every single partner before industry can take action. Geraint first, and then Michael.
Again, just one additional point here. When we understand the different measures out in the action plan as things that at some point connect, or I mean, there was already the mentioning of the alliance maybe leading to an important project of common European interest. I mean, there we talk about member states' money, no EU money. And therefore, I think it's absolutely necessary to make that link, at least for this purpose. And if it even would lead or may lead or prepare or buy into a joint undertaking, could be the same thing if it would be after a partnership, after the model of the CHIPS JU in a tripartite way, then again, funds of the member states are essential for making this fly. So that would be my additional perspective on this. Thank you.
So, what I would like to add, at the moment in our SDV activities, we concentrate on this non-differentiating hardware and software platform. That's what we're doing. If we go to these applications, what you mentioned, or parking, or all these others, we are going somehow into these differentiating use cases, and that's something which we have to tackle. My proposal would be taking into account that we have very different communities. We have the road operators. We have to find like easy parkers or parking operators. We have to find the charging operators, the energy, the weather, and so on. That we learn to create also governance with these combined communities. And I would suggest to have, as we do in Austria, with use cases, specify the use cases, have specific workshops then, with the specific experts, and identify what are the extensions we have to do in our platform, which are application specific, but still should provide the interface to another building block in the cloud, which does then the communication, and you need software out there, which I guess it's beyond the scope of our platform activities, which are in other initiatives which are out there on the cloud side. But we have to combine that. I would not recommend to put everything into one governance institution. It would be too heavy. but establish some kind of a use case-driven inter-domain coordination, which is needed. Otherwise, it won't work.
Yeah, and maybe one additional comment that really refers to the strategic dimension of what we're talking about. That's great to have the initiative of the European Commission on software-defined vehicle. I think it's something that has really changed the way, even in our partnership, that is not direct, so kind of indirectly affected, long-term affected, of course, the thinking about essential architectural matters, right? And I think this momentum, or I would hope this momentum can be kept in coordination with the member state, because the public authorities, in their role of being regulators, funders, policy implementers, and so on, are having such an important role to play on the long term to provide the framework conditions under which change and transformation is possible. So that would be, I think, the additional role that we can hope to receive from that coordination. Yeah.
Thank you. Okay, we're running out of time, so we'll take one final round of questions. I know, David, you had a question. Anyone else still raise? Otherwise, David, please.
So my name's David Storer. I work at CLEPA, the European Association of Automotive Suppliers. So thank you very much to all the speakers. I think it's been very interesting, very clear. And we as an association very much support the Alliance and also the future automotive partnership. Really important for our industry. But my question is this. So it's clear that cloud computing plays a central role here in everything we want to achieve. But today, the cloud computing providers tend to be American companies. I would like to understand, your opinions on whether or not that could be a risky situation for us. Also because presumably in the States, they are going to do something similar. And so the essence of competition may, rear its head. So, what's your position on that?
Yeah, I'll have a quick comment, and then if anyone else wants to comment, I'll give you 30 seconds to say something. So really quickly, yes, of course it is a concern. If you look at the US Cloud Act or FISA 702, there are several theoretical but still tangible security concerns on running on public clouds. Nevertheless, we have to start from realities and see where the hyperscaler market is, and we can't just completely neglect the hyperscaler presence in Europe. What I can say, particularly if we look, let's say, from the central data centers out to the edge, hyperscale cloud providers won't provide the far edge services that are often critical and needed for advanced connected and automated driving. That is an opportunity, also an opportunity to build up European capacity that is forthcoming with the Cloud and AI Development Act to really focus on sector-specific application areas where Europe can advance strategic autonomy. That being said, of course, there is a role and an engagement that is currently present and that will likely be present in the future with the hyperscalers. We have to be realistic on that.
Oh, go ahead, please.
So I think you raised a very, very valid point. So I can see it from our point of view. We are a foundation. We are open to anyone, so regardless of being from the US or not. And our members that are hyperscalers are American. So we don't have a European hyperscaler because there are none. Unless I miss something obvious, but because there are none. And yes, and all the projects we have in the cloud are driven by them. Which is on one hand, yes, worrying for the European leadership. But on the other hand, this is a way to learn from them. And what we do, any open source project is going to be vendor neutral, which opens the doors, as I said, so not only from learning from the people that know really well how the cloud works, but also for making sure you are not vendor locking in. So that opens the door for other initiatives that are European-led and European-based. So there is a trade-off, and I think the solution to this trade-off is contribution and engaging with initiatives that are already running so that you can start not from scratch, but from where the best already are at.
Thank you. If no further comments, we'll quickly go to the poll, if that's possible. Kostas? See if this works. No. Thank you. So we have 8 responses. We still encourage you to have more to submit. So how can European SDV collaboration enhance speed? Create business model, cost reductions, cooperation with MNOs, common APIs, and interoperability. Any comments from the panel on aspects that you think should be highlighted here or that resonates with you?
Well, I can only state that co-development is obviously something that resonates with us.
What maybe missing is also that with our European SDV collaboration, we can also help to speed up this transition in the development style, development tools. Also, I guess here Eclipse plays an essential role because you are since many years working in that area, bringing AI to speed up development. I guess that's something. The other thing is, which I guess where we still have to start to work to create also some kind of a structure of the software stack in the cloud. And that's more difficult because you will have different clouds. We have a concentrator and so on, so that we have other topics. That's something which I would see CCAM also in a leading role, because connected vehicles only work if you have a connection to not just to vehicles, but especially to do different communities in the cloud or different platforms in the cloud. And that's something where we have to start to work. I guess a joint project would maybe help.
Yeah, I see a couple of references here to avoiding duplication, making the usage of knowledge more efficient, and so on. But I would add that this is not the only opportunity. The even bigger opportunity that I see with applying software development processes to a traditional vehicle development process puts in or provides the opportunity of implementing agility and to speed up by that, not just by avoiding these things that are obvious, but there's more of that. I believe one of the questions that talk about the roadmap. Where are the milestones of that? The milestones are probably there where we connect the different development phases and make them more agile. Yeah. And that is, I think, is a great opportunity. I think that's something that in the software development world has been implemented for ages, but it's new to the mechanical world.
Great, thank you. 2 more quick points before we leave you out for your break. Kostas, if you go to the next one. I think if you go poll and then either left or right, I think you have to go left down here. Okay, so 0 responses on this one. So obviously you're not engaged in that one if we go to a previous one. Okay, so not a lot of enthusiasm on the polls, never mind. Thank you very much for your participation. I want to thank the panelists for their great contributions. If you have any further questions, feel free to approach us. But thank you so much, and let's give another round to the panel.